Well folks, welcome back to the workshop. Today, just have a wee quick one for you today. Repairing a Makita 18V cordless SDS drill. This is the DHR202. This is the older Makita cordless SDS drill, the one with a brushed motor, not a brushless one. Decent enough little machine, but only good for later sort of work. This one seems to have lasted anyway. It's actually from 2016. See what's wrong with it, see if we can fix her up. Right, generally what happens with these is the same as the brushed Makita drills or saws. The actual brushes inside of here overheat, they burn, they melt into the holder, they get stuck together, and eventually this thing stops running. That's not what's happening here. This one is actually burnt out. You can hear that motor struggling to run. So this is going to need a full strip to change the armature on it. We'll have to check the field as well to see if that there's gone weak. Also need a new set of brushes on it, and we'll check the holder as well, just in case that's actually melted as well. So tear this down and see if we can get her fixed up. So this is how to put a new motor in a Makita DHR202. First off, pull out the actual motor section. Now, don't need to go onto this side at all. The actual gearbox should be fine. Leave this completely alone. Just pull out the whole motor. As you can see, that is well burnt up. Tell by the colour of the com bar, the actual colour of the windings too. So that got very hot. I'm surprised if the field's still good in this. And that's why I didn't bother pulling out the brush caps before pulling out the motor, because I knew this was already burnt out. More than likely they were going to be melted. But these are melted onto that brush holder, so those brushes aren't coming out, and them caps aren't actually coming off the brush holder. So I have to replace that as well. So this is what we want to know. Actually, that's alright. Still plenty of force in that magnet, holding it in place. If you're to put that on and it just slides on, no real resistance, you can just pull it on and off, no problem. The magnets have gone weak. And if you put a new armature on with a weak stator, it'll probably run a little bit fast, but it'll draw a lot of current to actually compensate for the less power here. So it'll actually end up burning out the motor or your controller on their switch an awful lot quicker. That one, that's fine. The brush ring then, have to replace that. 2/2, because these are all melted up. Brush is melted solid onto that holder. We'll have to replace the brushes, and we'll have to replace the caps. I'll say this boy knew it was running badly because they actually look like new brushes that's on it. See, this was starting to slow down. I changed the brushes to see if that would fix the problem. It didn't, but he's ran them on anyway. Eventually melted them on. As well, take note of which side's which. These leads have to go back on the same way. Not do the machine any harm if you reverse the leads, but it'll actually reverse your forward reverse switch. So whatever position you're used to it being in, if we're going forward, it'll be reversed over. Not a big deal, but a lot of people find that very annoying if you change it. So make sure you put your leads on to the right place. First thing is a brush holder. It costs about €13. That's the part number there. Them caps are destroyed, we'll have to replace them as well. Sticking these leads on, it's not just handy to put them on one at a time so you don't mix them up, but having one still on allows you to line up these here wee ring connectors as well, because sometimes in the likes of a drill or a wee impact driver there's a lot less space inside the actual tool. These can be sitting in an exact angle or sitting in an exact way, so if you just stick them on straight they actually get in the way of the housing. So by leaving one attached allows you to line them up to the exact same position again. Not as big a problem in this one, mind you. So make sure your lead is actually tucked into there on the brush holder. Drop that down into place. Lead's just coming out this little hole here on the housing. Same with the other one. Tuck that lead on. Drop it in as well. They're sitting there. This little black piece is actually sitting in this opening here. Plenty of space for it. And just screw them into place. After that, drop this boy in. This is actually just your MOSFET for controlling your speed for your switch. And it's just sitting on a brass plate to act as a heat sink to keep it cooled down. And I'll just sit up in there. Flat washer just sits in there for it pushing against the bearing on the armature. The actual change lever for your switch sits in there. Lastly, your field, just give that a wee clean as well. As well as that, give that housing a bit of a wipe as well. It's not going to make any difference to how it works. It's just nice to keep it clean. Your field itself can't actually fit this wrong. Little hole cut out in it here, a little notch in the body. A little notch goes onto the hole, so that's the only way that can fit. Won't fit in that way or any other position. Won't actually close up for you. It has to be sitting just there. That field has to be in the right orientation, otherwise magnetic field generated by your armature when she's running won't interact properly with this magnetic field on the permanent magnet. So if that position's wrong, these are going to be energizing at the wrong position and it'll be fighting itself instead of trying to go in one direction. So that's that. That's everything inside of here. Just make sure your forward reverse switch is working before you screw it together. Now this little housing here, this is a separate little housing. That is to take the vibrations away from your battery whenever you're using this here hammer drill. So obviously this is going to be doing a lot of vibrating. If this was fixed to this housing, the battery is going to move around an awful lot. It'll end up burning out the contacts on the tool and on the battery. So having this separate, these little rubber mounts, allows this to vibrate instead of the battery. As well, don't forget on this wee metal pin, little rubber roller to help guide the battery in and hold it tight. As well, on the extra battery housing here, if it does become too slack and moving around too much, becoming annoying, you can actually replace the two little rubber mounts if you wanted to. Only cost like 50 cents or €1 each. So that is that half ready. Now we need to replace the armature. Simply held in with the bearing. Pull it out. Your sealing behind should be fine. and that's your blown armature. Now the replacement costs around €40 plus the VAT, and that's your part number there. As you can see, it's meant to be a nice bright colour, not all black and darkened like this one. And as armatures go, they are actually quite good, all potted and resined around here. On the bottom, they actually have an NSK bearing from Indonesia. A newer one, again an NSK. The older one actually had a Koyo bearing, which is a Japanese one. They actually do use good bearings on them. The thing that kills them is generally abuse, using them for things they're just not really designed for. Cordless tools like these can draw a lot of amps, which generates a lot of heat. So if you're dogging these things, putting a lot of pressure on it and running for an awful long time, these can suck 30 amps out of the battery, which produces a lot of heat inside the actual motor. So all that heat is going to start damaging the motor. They're good for light sort of work or for small odd jobs, but not for everyday heavy use. Likes of a 5 or 7mm butt, it'll be grand drilling that for most of the day. But once you get onto the bigger butts then, 10, 15 or 20mm, you really are pushing them. So the new armature just pushes in. Before we put it on, just going to put a little bit of extra grease on here. I'm only putting on like 10mm or so, very little. You don't even need to put any in, I'm just putting it on because I have it here. The motor then should just push in, same way as it came out. Little jiggle, and you'll feel it get on until it's solid. That's it. That can just slide straight onto here. Make sure your two halves actually come together, and they don't have to squeeze it on for it to close. If it's not sitting neatly like that, and there's a gap like that there, and your armature is not pushed on far enough onto the gear housing, it should sit nice and flush. And lastly, a set of brushes and a set of caps. Caps are only 80 cents each. And that's the number there if you need them. The brushes, the right number is CB441. They're the proper brushes. They cost around €10. Or if you're stuck and you can't get them, you can also use CB442s. It's the exact same size of a brush, but they just work out a little bit more expensive. These are a better one to use. They'll do in a pinch, but they cost €13. You're better off using the proper ones. That's it. One new motor, armature, brushes, caps and a brush holder, and a Makita DHR202 from 2016. Should get it running like new again. That's her. Now, just give it a quick test out. That's her. up and running again. Not so bad. 2016 machine. That repair altogether, including the parts, labour and the VAT, cost €82. To replace the drill itself, to buy a new body only, you'd be talking at least €180. So fixing it, putting a new motor onto the old one, saves you at least €100 in the machine. So if you have one yourself, that's how you actually replace the armature, brush holder, brushes and caps, and the Makita DHR202. That's her, folks. Thanks for watching. As always, give us a wee like and a follow if you're liking the tool repair videos. Cheers, folks.